One of the things that also comes up is we like to look at functions that are either graphed or maybe we're given some table information about a function and its derivative. But if we actually have the graph of this linear function f of x and the graph of this linear function g of x, let's let h of x equal f of x times g of x. In other words, h of x is going to be the product of these two functions. And let's say that I want to find h prime of 2. Let's just see if we can use the product rule just kind of by its definition and then apply things and see if we can't find out the information that we're going to need to find h prime of 2. Well, I know if I want to know h prime of 2, I need to substitute 2 into the derivative of h, which means I need to know what h prime of x is equal to. Well, h prime of x, if h of x is the product of these two functions, I'll use my product rule, which says it's the first function, f of x, times the derivative of the second, g prime of x, plus the second function, g of x, times the derivative of the first function, f prime of x. And so if I want to know what h prime of 2 is, h prime of 2 is equal to f of 2, g prime of 2, plus g of 2, f prime of 2. So now let's kind of come over here into this blank space and see if we can't figure out what the values are for each of these things. If I take a look at the values for f, I need to know f of 2 and I need to know f prime of 2. So f of 2, I need to figure that out from the table. I also need to know f prime of 2 from the table. And then the same is going to be true for the function g. I need to know g of 2 and g prime of 2. Well, let's start off with f of 2 and g of 2, which are going to simply be the function values at 2. F of 2, here's 2, is going to equal this point 2 comma 4. So if I have the point 2, 4, then f of 2 is simply equal to 4. And I'll do the exact same thing with g. G of 2 is equal to this point right here at 2 comma 1, so g of 2 is equal to 1. Now I need to know what f prime of 2 is and what g prime of 2 is, and this really just kind of tests your understanding of the vocabulary here. Remember, f prime of 2 is the rate of change at 2. Well, for a linear function, I always have a constant rate of change, which we call its slope. And so f prime of 2 is really just a fancy way of asking what's the rate of change of f of x at 2, or in this case, the slope. And if I take a look here, I have the point 0, 2, and then I can just go back to kind of rise over run and look at this and say I go up 1 over 1, up 1 over 1, so f prime of 2 is equal to 1. If I look at g prime of 2, it's a little bit steeper. I've got this point at 2, 1, but it also looks like I've got the point at 3, 3. So I can say I go up 2 over 1, and so g prime of 2 can be equal to 2. And now I've got all the values I need to go back here and say, okay, h prime of 2 is equal to f of 2, which we said was 4, times g prime of 2, which we said was 2, plus g of 2, which is 1, and f prime of 2, which was also 1. And so h prime of 2 comes out to be 8 plus 1, or h prime of 2 is equal to 9. And really what this came down to was, could you apply the product rule and get this expression right here? And then when you looked at the graphs, and you can give a table as well to figure this out, do you understand what it's asking for when it asks for f of 2 or g prime of 2? Remember, f of 2 and g of 2 were the function values at 2. F prime of 2 and g prime of 2 were the rates of change at x equals 2. And since we were dealing with linear functions, we had a constant rate of change. And so we were able to figure that out just with rise over run. But notice we weren't given f of x equals or g of x equals. We just had to surmise this information right here from the graph, but we were able to do it pretty easily and then apply it to our work within the product rule.